Hello. So these are some notes that I didn't get a chance to go over in Block 5 class today that I want to go over so you can complete your last two homework assignments. So let's talk about solving by factoring. So when we're solving by factoring, it's pretty much what we did in class. The only difference that I want you to take a look right here is notice that instead of saying y equals or f of x equals or g of x equals, it's negative 3x squared plus 4x equals 1 plus x squared. So it's kind of in a scrambled form, okay? So the first thing we need to do, if we look at the directions, okay, is we need to set each equation equal to 0. And we need to make sure the terms are in descending order. Descending means it goes down from the highest power to the lowest power. So if I make my equation equal to 0, what I need to do is I need to move this 1 over to the left by subtracting 1. And I need to move this x squared to the left by subtracting x squared. So I have a total of negative 4x squared plus 4x minus 1 equals 0. So that is setting the equation equal to 0 and putting it in descending order, because notice it goes x squared, x, no x. Okay. Now, I personally do not like starting with the negative. Okay, that's one of my pet peeves. So I'm going to factor out a negative, and I'm going to see is there anything else they have in common. And they don't have anything else in common except for a negative 1. So when I factor out a negative 1, factor meaning to divide, I get 4x squared minus 4x plus 1. So then I have that orange negative 1 that's hanging out, just enjoying things. And I'm going to try to factor that trinomial, that 4x squared minus 4x plus 1. So I'm going to factor it using the x method. And I'm going to go, what times what makes 4x squared and adds to negative 4x? So if I take a look at this again, what times what makes 4x squared and adds to negative 4x? Well, hopefully you go, it's negative 2x and negative 2x. So if I were to do the box method, I would put the first term in the first box, which is 4x squared. The last term in the last box, which is 1. And then the negative 2x and the negative 2x in the middle boxes. Now be careful, if you're using the box method, it's very careful that you follow the arrows. So going to the left, what does 4x squared and negative 2x have in common? They have a 2x. What does negative 2x and positive 1 have in common? Notice it starts with the negative. So you need to factor out a negative and they both divide by 1. Okay. Going up, following the arrows. What does 4x squared and negative 2x have in common? They both have a 2x. And what does negative 2x and positive 1 have in common? Notice it starts with a negative. So I'm factoring out a negative and they both divide by 1. So my factors, my two parentheses, one is 2x minus 1, and the other one is 2x minus 1. So this is what we called factored form. Now, what do you notice about both parentheses? Do you notice that both parentheses are exactly the same? And because they're exactly the same, they're going to produce the same x value. So if I add 1 and divide by 2, x equals half. So that means my x-intercept is at half comma 0. Now I'm going to go ahead and I'm going to count by halves just because half is a small number. So I'm going to count by halves and put that right here. And I forgot to answer this question. Is this parabola going up or down? This quadratic function, is it opening up or down? So opening up, right here, just to make sure that we got this. If it opens up, this is called a minimum because the vertex would be the lowest point on the graph. And if it opens down, this would be called a maximum because the vertex would be the highest point on the graph. Because this problem starts with a negative 4x squared, it is a maximum. It's going to be facing upside down. Okay, so the y-intercept. So when I go back and look at the equation, the equation once we put it together, remember it was negative 4x squared plus 4x minus 1. What is the constant term? So the constant term in this particular case is negative 1. So our y-intercept is 0, negative 1. So remember counting by halves, so half down and then 1. Okay, the axis of symmetry. The axis of symmetry is always between the two x-intercepts. But be careful, I have two x-intercepts that are exactly the same, which we call a double root, not Dr. Pepper. So the DR, doctor, right? Double root, so DR is double root. So if I had two x-intercepts exactly the same, half comma 0 and half comma 0, where would the middle be? Well, the middle would be at half and half, between the half and half, the middle is half. So our x-axis of symmetry is x equals half. And to find the vertex, you always plug in the axis of symmetry, either into the original problem or the factored form. I like to plug it into the factored form personally. So I'm going to go ahead and plug that in. And plug in a 0.5. So I have negative parentheses 1 minus 1 parentheses 1 minus 1. So negative times 0 is negative 0. And by the way, there's no such thing as a negative or positive 0. It's just 0. So the number I plugged in was half or 0.5. And the number we got out was 0. It happens that our vertex is also our x-intercept is also our vertex. Okay. So if you're taking a look at this, you're like, well, how do I connect this parabola when I only have two dots, the one in blue and that one that was in orange and black happened to be the same dot? Okay, well, if I were connecting them going upward like this, we know our parabola is not going up. We know it's going down. So it has to be going downward like this. But the thing is the axis of symmetry is what cuts that parabola in half. So if half of it is to the left of that green line, the other half of it has to be to the right of that green line. So let's see, that blue dot is one space to the left, like half a space, but we call it one space because we're counting by halves. So if I go one space to the right, now I can connect my parabola a little bit more accurately. Let's do one more just to make sure that we have it. So 9x squared plus 3 equals negative 22 minus 30x. Let's see if we can go a little bit faster on this. So the first thing I want to do is I want to set my factors equal. Set my terms equal to 0 because it's kind of scrambled right now. It's not y equals, not everything is on one side of the equal sign. So I'm going to move this negative 22 over by adding it. And I'm going to move this negative 30x over by adding it. So when I combine like terms on the left-hand side, I have 9x squared plus 30x plus 25. And again, it's really important that you put this in descending order, okay, when you're graphing. So descending order means it goes x squared, x, no x. Now this one doesn't start with a negative, so I know it's going upward, so it's smiling and it's like, yay, almost to the next set of vacation holidays, right? And so since it's going up and it's smiling, that means the vertex is at the lowest point on the graph. So we call that a minimum. So I want to factor this to find my x-intercept. So if I were to draw my big X, and I were to take the first and last number, which is 225x squared, and our middle is 30x, I ask myself, what times what is 225x squared and adds to 30x? Well, it's not 1 times 225. Well, 5 goes in. So let's see here. Could it be 5 and 45? And I completely forgot. I don't know what made me skip over, but it's 3 and 75. I was supposed to go in order. 1, 3, 5. 6 doesn't work. 7 doesn't work. 9 works. 9 and 25. Okay, 10 doesn't work. 11 doesn't work. 12 doesn't work. 15. What about 15 times 15? So which one of these choices, hopefully I didn't skip any, would multiply to 225 and add to 30? And that happens to be 15x and 15x. Now you're more than welcome to use the box method, but I'm actually going to show you, instead of using the box method, what I was doing in class. So if I drop the first term, which is 9x squared, and I drop the last term, which is 25, and I'm going to rewrite the middles. So instead of 30x, I'm going to replace it as 15x plus 15x. So what do the first two have in common that I can factor out, and what would be left? And what do the second two have in common, and what would be left? Well, the first two, 9x squared and 15x both have a 3x in common, and what's left is 3x plus 5. And what does 15x and 25 have in common? They both have a 5, and what's left? 3x plus 5. Now, these parentheses have to be the same. If they're not the same, you did something wrong. So our factors are 3x plus 5 and 3x plus 5. And just like the last problem, this was on purpose, they both have the same parentheses, which means they're both going to produce the same x-intercept. If I were to set my factor equal to 0, my x-intercept would be negative 5/3. So my x-intercept is negative 5/3, comma 0. And I'm going to put dr because there's two of them. So double root is just letting people know that you're getting two answers that are exactly the same. We're going to go in more detail about that when we start going over polynomials, which is the next unit after this. Will be after the holidays. Okay. So negative 5/3. So it's up to you what you'd like to count by. I think I'm going to count by 1/3. Why not? It's not like I have a bunch of numbers. So 1/3, 2/3, 3/3, 4/3, negative 5/3 would be 5 spaces to the left since I'm counting by thirds. and then my y-intercept. So remember, for y-intercept, it is always your constant term. So in 9x squared plus 30x plus 25, which one is our constant? Well, our constant is 25, so our y-intercept is 0, 25. And no, I don't want you counting 25 tally marks, especially if you're counting by thirds. So just put a dot way at the top and put 25. Okay, our axis of symmetry is always the middle of our two x-intercepts. Well, if I have two x-intercepts at -5/3, the middle of -5/3 and -5/3 is just -5/3. So I have an axis of symmetry at x equals -5/3. Don't forget the x. Okay. And how do I find my vertex? Well, I always plug in my axis of symmetry either to the factored form or the original. I prefer the factored form. So I'm going to go ahead and plug in -5/3 for x. I didn't change it to a decimal on purpose. It's okay when it's halves or quarters, but it's usually not a good idea when you're talking about thirds or sixths because it doesn't divide perfectly. So right here, 3 times -5/3, the 3 multiplying and the 3 dividing would cancel out to 1, so it'll be -5 plus 5, which is 0. And the 3 times -5/3, again, the 3 multiplying and 3 dividing would cancel out to make 1. So you're left at -5 plus 5, which would make 0. And 0 times 0 is 0. So what number did we plug in? We plugged in -5/3. And what number did we get out? We got 0. So just like the last one, our x-intercept also happened to be our vertex. Okay. So we know this parabola is going up. So therefore, I don't want to go like this. You see how that would be going down. That's not correct. I want to make sure it's going up. And we know that the axis of symmetry is what makes a parabola symmetrical. It's what cuts the parabola in half. So if I have that orange dot to the right going up, I should have another orange dot going to the left going up. Let's see how many spaces that is away. It's 1, 2, 3, 4, 5 spaces kind of going from the axis of symmetry, 5 going to the right and up 25. Remember, it's not really 5, it's like 5/3 going to the right and up 25. So if I go 5 to the left, 1, 2, 3, 4, 5, and then go up 25, this is like -10, 25, but again, because we're counting by thirds, it's -10/3, 25. And then when I connect my parabola, it looks something like this. All right, so next thing I want to go over really quickly has to do with the area of the pool. Even though we did area in class really quickly, it was a quick problem. I want to go over it in a little bit more detail. So this is the one that has to do with the CSI homework. And the CSI homework for right now, you could use Desmos to help you. In the future, I'm going to show you how to do this without using Desmos, but we're going to use Desmos to help us out right now because that's what the problem is asking us to do. The area of a rectangular pool is 640 feet squared. So I'm a very visual person, so I'm going to draw my pool. And I know that area of a rectangular shape is length times width. So I can replace the area with 640. And the width is 12 feet shorter than its length. The width is 12 shorter than length. Well, did they give us any information about length? I don't think so. I don't know what the length is. So what if I call the length x? So what would 12 shorter than the length be? Well, then that would be x minus 12, not 12 minus x, because the length is the longer side, so you have to do the longer side minus the amount to get the shorter side. So that means x times x minus 12. So I'm going to go ahead and I'm going to use Desmos because that's what this CSI project is, and it's going to lead us into what we're going to be doing the next time we're meeting. So I'm going to go ahead and open up another tab right here to Desmos. And I'm going to type in 640 equals x times x, the quantity of x minus 12. And of course, I can zoom in and I can zoom out by pressing these plus and minus signs. Now, just know that you don't need to see the whole graph to get the answer. You already know, or hopefully you know, that this parabola is going up, because if I were to distribute the x, right, by the way, this right here is part A, but if I were to distribute, I get 640 equals x squared plus 12x. I know this parabola is going up. I don't need to know the whole thing, what it looks like. What I need to know is my x-intercepts. And the reason why I need my x-intercepts is because I'm looking what x equals, right? So I need what my x-intercepts are. So I'm going to look at the graph and I go, okay, well, where are my x-intercepts? So I notice my x-intercepts are positive 32, 0, and negative 20, 0. So I'm going to go back here, 32, 0, and negative 20, 0. So this right here is one x-intercept, and this is my other x-intercept. So that means x is negative 20, and x is 32. Well, x refers to the length. Can you have a negative 20 length? The answer to that is no. So x has to be positive 32. Positive 32 what? Okay, it represents 32 feet. So my length is 32 feet. So my width is x minus 32. I'm sorry, yeah, x minus 12. I don't know why I said x minus 32. That was silly of me. So 32 minus 12, which happens to be 20. Okay, so our length is 32 feet and our width is 20 feet. So the dimensions of this rectangular pool is a 32 by 20 foot. Okay, so this is also for the CSI homework. And I went over this briefly, very briefly in my period 4 AM class, but I didn't get a chance to do it for my period 4 PM class. So I want to go over a little bit more. And CSS, that's not wrong. CSI homework. And again, we're going to use Desmos. So suppose an astronaut on the moon kicks a soccer ball with initial velocity of 16.5 meters per second, 1 meter above the ground. The acceleration due to gravity on the moon is roughly 1.6 meters per second squared. The same astronaut on Earth kicks a soccer ball with initial velocity of 16.5 meters per second, 1 meter above the ground. The acceleration due to gravity on Earth is roughly 9.8 meters per second squared. We want to use this formula to kind of help us out here. Okay. And the question, which I forgot to, let's see. So we want to use our formula to determine how much longer will it take the ball to land on the moon compared to the Earth. Now it looks very overwhelming because we have a bunch of words, but some of you love history and English, so therefore you'll love these words. So let's work together on this. We know we are talking about Earth and we're talking about the moon. So let's just write some information. So here's Earth. And here's the moon. Same formula, because we're both kicking the soccer ball. Just one happens to be on the moon and one happens to be on the Earth. So let's find all the information about the Earth, and we're going to put it in blue. So the astronaut is kicking the soccer ball with the initial velocity of 16.5 meters per second. Okay, so initial velocity. Well, initial velocity is v. So I'm going to replace the v with 16.5. And then it says 1 meter above the ground. Okay, so what is this 1 meter above the ground? Where does that go? So 1 meter above the ground. Let's see. So capital H is the height of the object after t seconds. And lowercase h is the initial height of the object. Well, we're kicking this initially. It's starting to be kicked. So that's the initial height. So little h is 1. Okay. We're going to skip the next couple sentences because it's talking about Earth. So I'm going to see, is there any other information, or actually, I just realized, silly me, I'm doing information about the moon. This is going to be Earth. Got them in the wrong spots. So let's see, is there anything else? Oops, here I got this information I forgot. It says the acceleration due to gravity of the moon is roughly 1.6 meters per second squared. So acceleration of gravity, so let's see, acceleration of gravity, that looks like it's g. So I'm going to replace the g with 1.6. So when I write this nicely, I have h equals -1/2 parentheses 1.6 t squared plus 16.5 t plus 1. Now I'm going to do the exact same thing. So this right here is the equation of my soccer ball that's kicked off the surface of moon. I want to do the same thing for Earth. So let's go back and see if we can read any information about Earth. Okay. So it says the same astronaut on Earth kicks a soccer ball with initial upward velocity of 16.5 meters per second. So that is V. And 1 meter above the ground, remember 1 meter above the ground, that's that initial height before the ball gets released, right when it's about to be kicked. And the acceleration due to gravity on the Earth is 9.8. So h equals -1/2 times 9.8. Oops, I forgot the little square. T squared plus 16.5 t plus 1. Now, the only thing different is because they're both very similar situations. The only thing different about the soccer ball being kicked off the moon and the soccer ball that's being kicked off of Earth by the exact same astronaut has to do with the gravitational force. So our formula should look fairly similar. Okay. So if I were to go ahead, I'm going to write these formulas down and I'm going to go to Desmos. So I'm going to go ahead because I want to compare them. I want to see how much longer the soccer ball is going to be take to land on the moon versus Earth. I'm going to go ahead and plug in the formula. So H equals -1/2 times 1.6 T squared plus 16.5 T plus 1. All right, and just so you know, if you need to, there is a keyboard right here at the bottom left. And then I'm going to go ahead and I'm going to copy this. I'm going to paste it. And now, since it's almost the exact same equation, the only thing different was the gravitational force. So I need to change that. Instead of 1.6 T squared, it's 9.8 T squared. So I'm going to change that. And you see the red one, which happens to be the moon, is significantly higher than the one that is in blue. So I'm going to go back and read the question and make sure that we answer it correctly. So the question that I'm going to highlight says, how much longer will it take the ball to land on the moon compared to the Earth? Well, the soccer ball is being kicked and then it goes up and then it lands right here, right? So kick, land. So that means we need to find my x-intercepts. Well, let's find the x-intercepts on the first equation, which was the moon. So if I find the x-intercepts on the moon, that's the one in red. Sometimes we need to hide it. So if you want to hide it, you can click on, you see what looks like a wheel or a flower. If you click on that, this is not what I was trying to do. There you go. You can kind of click on it and make the second equation temporarily disappear. So if you were taking a look at it, and I wanted to find the x-intercepts, it's approximately, now it's not perfect, right? But we're going from negative 0.06 to positive 20.685. So again, this is negative 0.6 or negative 0.06. I apologize. And then this right here is about 20.685. So what is the distance between here? So if I take 0.06 and I add it with 20.685, the distance equals, and so I'm going to use my calculator and add those up. And it comes out to be about 20.745. Now let's do the one on Earth. So I'm going to go back and let's erase that. Well, not erase it, but temporarily get rid of it and click on that Earth one that we have in blue. And let's find the x-intercepts. So from that one, it looks like it's going from negative 0.06 to 3.427. So let's put that down on paper so that we know what we're talking about here. So negative 0.06 and 3.427. So if I wanted to find the distance, I would add those numbers up. So if I use my calculator again to add those up, I get approximately 3.487. So how much longer would it take to land on the moon compared to Earth? So we take the moon distance or time. I don't know why I'm saying distance, but the time. So distance and time. So which is 20.745. And we're going to take the distance as time for the one that's on Earth. And I want to subtract them. And the reason I'm subtracting them is I want to figure out how much longer it's going to take to land on the moon compared to Earth. So I want to subtract those numbers. And I get 17.258. So it's going to take 17.258 seconds longer for the soccer ball to land on the moon compared to Earth. And the last part that I want to show you is how would you write the equation of a parabola if you were given the graph? So always want to start with y equals or f of x equals or g of x equals. Well, today, this is Wednesday, and even though my fifth period is not on Wednesday, I'm going to put w of x. It's been a wonderful Wednesday so far. Okay. So I'm going to take a look here, and I notice that my vertex is right here at 4, 0. And I only have one vertex. Well, normally you have, well, yeah, it's not just one vertex. It also happens to be my x-intercept, right? One vertex, one x-intercept. So that tells you that normally you're supposed to have two x-intercepts. So this is what we call a double root. Anytime you only have one x-intercept, it's a double root when you're talking about quadratics. So since our x-intercept is 4, 0, that means x equals 4. And before I solved for x, if I move the 4 over, it's x minus 4 equals 0. Now remember, it's a double root because I only have one x-intercept, which means there's technically two that give you the exact same value. So that means I have to have two factors of x minus 4. So I'm going to write x minus 4 2 times. So this is your answer in factored form. So how would I write this in standard form? Okay. So if I want it in standard form, then I would go ahead and I would multiply x minus 4 times x minus 4. So it'd be x squared minus 4x plus 16. And when I combine like terms, it'd be x squared minus 8x plus 16. So this is what it would look like in standard form. One more problem just to make sure you got it. So let's take a look at this one right here. So we're going to find our x-intercepts. Happen to be at -2, 0, and 4, 0. So again, these are x-intercepts. So that means x equals -2 and x equals +4. Well, before I solved for x, it was x plus 2. And before I solved for x, it was x minus 4. So in factored form, so tomorrow is Thursday. So t of x equals x plus 2 times x minus 4. Now be very careful. It's going upside down. And since it's going downward, it means it starts with a negative. So how would this look like in standard form? So standard form means you put it together again. So t of x equals. Now, if you don't like doing the box method, you know you can FOIL. So you can leave the negative on the outside. And if you FOIL, you go first. X times x is x squared. Outer. X times -4 is -4x. Inner. 2 times x is 2x. And last, 2 times -4 is -8. Now that negative means to distribute. So if I distribute, I get -x squared plus 4x minus 2x plus 8. And when I combine like terms, because I can combine those, that 4x and that -2x together, it'll be -x squared plus 2x plus 8. Please come in for tutoring if you need absolutely any help. Mondays from 1 to 2, Tuesday and Thursday from 3:15 to 4:15. Have a great rest of the day.